anytime that we are converting from either degrees to radians or radians to degrees, we need some kind of relationship to show an equivalency between degrees and radians. So some people use 2 pi is equal to 360 degrees, one full lap around the circle, or it's easier if you just do a half a rotation around the circle. So 1 pi is equal to 180 degrees. Which means, so this is like your conversion factor, just like you would say there are 12 inches in a foot. There are 180 degrees in pi radians. And so if I want to convert from radians to degrees, if these are in radians, I want to put the number of radians down here and the number of degrees up here. And so I'll divide by the number of radians, and then I'll multiply by the number of degrees, and that will cancel out these units of radians, and that'll leave me with units of degrees. So I'm going to put pi radians down here and 180 degrees up here. Now you should recognize that what I'm doing here is I'm multiplying by the number 1. Even though they're in different units, the quantity of 180 degrees is exactly equal to the quantity of pi radians. So this fraction is just the number 1. So I'm essentially multiplying the value of this fraction by the number 1, which means I'm not changing the quantity of it any. I'm merely changing how that quantity is written, how it's described, what units we report that quantity in. And so if we do this, we just have to be a little bit careful with our algebra here. So I'm multiplying across here, and then I'm going to be dividing here. But basically these pi's are going to cancel out. You have 1 pi in the numerator and 1 pi in the denominator, so it's going to cancel out. And you could treat this 180 as like it's over 1, and so the 6 and the 180 can simplify. You can divide 6 into 6 one time. You can divide 6 into 180 30 times. 6 goes into 18 3 times, and then you leave the 0. And then the pi, so now what I have, let me just rewrite it this way, is I have 13 pi times 30 divided by pi, right? So the pi's cancel out. So basically my answer in degrees is going to be whatever 13 times 30 is. Well, we could do that by hand here if we don't have a calculator. 3 times 0 is 0, 3 times 3 is 9. Put a 0 to start the next line. 1 times 0 is 0, 1 times 3 is 3, so it would be 390 degrees. In order to convert from degrees to radians, we are going to do the exact same thing, just kind of in the opposite direction. So again, we need that conversion factor, and we know that pi radians is equal to 180 degrees. So if I have negative 36 degrees, and I want to convert it to radians, well, now I need to divide by degrees, and I need to multiply by radians, and that way my degrees will cancel out and I'll be left with radians. So I'm going to put my degrees down here, 180, and I'm going to put my radians up here. And again, this is just the number 1. Pi radians is the same amount of angle as 180 degrees is. So this is just 1. I'm just changing the way that I'm representing this. And so you can see that this gives you negative 36 pi over 180 radians, but we want to simplify that fraction. My degrees cancel out, so I have radians. I want to simplify that fraction. So I can divide them both, let's see, I could start by dividing them both by 6. And so this would be negative 6 pi over 30. And then you can divide them both by 6 again, and you get negative pi over 5. So negative 36 degrees is equivalent to negative pi over 5 radians. And the negative is just indicating, again, that we're going around the unit circle clockwise rather than counterclockwise, how we normally go. And so if you're going around counterclockwise, if you're going around clockwise with your degrees, you'll also be going around clockwise with your radians.